Hey, what's up? Let's do some math today. So in this video, we're going to talk about an introduction to polynomials. Now, polynomial is a very intimidating word. There we go. It's a very big word. But really, my goal here is to sort of break it down for you and explain what it is. Once we wrap our mind around this big, nasty word, what we have to do with it becomes a lot easier. So essentially, when we're talking about polynomials, I want you to think about algebraic numbers. Algebraic numbers. Now, this isn't the literal definition, but we've already been dealing with polynomials. We just haven't called them polynomials up to this point. So, for example, an algebraic number is something like x. It could also be something like x plus y. It could be something like x squared minus 2y plus 5. All right. Now, each one of these things we can kind of categorize as a number. So x is just some number. X and y could also be considered as a single number. Like if we had values for them, we would add them up and we'd have a solitary number to deal with. Same thing here. If we had values for x and y, we could plug it into the expression. We could figure out what it is. So really, in the eyes of algebra, this is a number. This is a number. This is a number. And eventually what we do with polynomials is the same thing you did with numbers when you were in like kindergarten, first grade, second grade, third grade, where it's like, okay, what happens if we add numbers together? What happens if we subtract numbers together? What happens if we multiply numbers together? And that's essentially what we're going to be doing throughout this unit, is we're going to take a look at polynomials and we're going to talk about how we can do different things with them. So again, when it comes to polynomials, think algebraic number. Now, if we're going to get with a little more technical, a slightly better definition of what they are, so let's put a better definition, we'll call it an algebraic expression of constants, variables, and whole number exponents. And that's what a polynomial actually is. So for example, if we take a look at something like x plus 5, this is an expression of a constant and a variable. And there are no exponents in this one, but therefore this would be considered this would be considered a polynomial. Now, let's take a look at another one. Let's say we had something like 5x to the third minus 11y to the fourth. This works because these are an algebraic expression with variables, no constant, but that's fine, or the constant would be 0. And everything is raised to a whole number exponent. Now, what would not be considered a polynomial would be something like the square root of x plus 5, because this square root is technically a non-whole number exponent, but that's a debate, or that's a discussion for another time. So this is not a polynomial. These are polynomials. Now that we've gotten that out of the way, let's talk about what it is you're going to be expected to do with these polynomials. That's not what I wanted to do. Let's try that again. Let's do it like this. And can I delete all that? Nope. All right. We'll delete it this way, old school style. All right, so now in our introduction, there's just a few things I want us to kind of be able to do. The big thing is determining the terms we have, and let me put that back on there, so let's go blue, G. Okay, so there's a big thing that we're going to want to focus on. We want to figure out terms and degrees of polynomials. All right, and what you're going to find out is that the math we're going to do today isn't all mathy, it's just more understanding what a polynomial is. So now, for a term, what we want to do is we want to look for pluses and minuses. And that's going to create a little division within our term. So for example, if we take a look at something like, well, I'm going to throw down some polynomials here. So let's say we have something like negative 3x. And then let's compare that to 4x squared minus 2. And then let's make one more. Let's go with x squared plus 5x plus 6. So what we're going to want to do is take a look for these plus or minus terms. Now, this one only has one negative. I wouldn't call that a minus per se, so I'm not even going to count that. But what we have here is one term. And there's a fancy word for a polynomial that has one term, and that is a monomial. Here, I'm going to look for my pluses and minuses, and what I found, let's use a highlighter. Oh, that's not a highlighter. Let's try that again. This is a highlighter. All right, here I have one minus sign, and what that gives me is two terms. So again, you want to look for the pluses or the minuses to help sort of separate out the terms here. And so as a result, this one has two terms, and the fancier phrase for two terms is going to be a binomial. All right, bi meaning two. All right, here, look at the third one. I have two plus signs, and so that means that I have 1, 2, 3 terms. Not sure if that's going to show up all that well since it's a light highlighter, but I have 3 terms, and so I'll write that down, 3 terms, and that's going to be a trinomial. Now technically, these are all polynomials. Poly just means many, and so it's not wrong to say that they're polynomials, but if we want to be a little more specific, it's saying it's a monomial, a binomial, or a trinomial. And then anything that's bigger than 3 terms, we just tend to say is a polynomial in general. Okay? And so the trick is just to look at the plus minuses to kind of use as a separation. Now, if we're talking about the degree of polynomials, this refers to the sum, actually, wait, I'm going to take that back here. The largest sum of exponents in a term. So let's start off with something nice and easy. X squared minus 9. The degree of this polynomial is going to be 2. Okay? Because of that right there. So that's my connection. I look for the largest exponent I have. 9 has a little phantom exponent of 1 there, and actually we wouldn't even count that because it's a number. I want to look for the variables, but since this is 2, my degree is going to be 2. All right, now let's say I had something like x cubed plus 4x squared minus 2x plus 8. I have a bunch of different terms, but what I want to do is have my I go to the largest exponent. And sometimes it might be hidden. It could be written in a different order, but right here I have my largest exponent, and that is 3. Now where it gets a little bit trickier is when we have something like this. Let's say we have x squared y minus 5xy plus 10. Okay, so what I'm going to do is look for my exponents. And here I have a 2, but I have to remember there's actually a 1 right here, and then I'm going to have 2 1s right there. And so I actually have, from this part right here, my degree is 3. Here my degree is 2 because I'm adding those 2 invisible 1s together. But I only want the largest one of a single term. And so the degree is going to be 3. And so once we start bringing multiple variables into the mix, it can get a little bit complicated. So let's just kind of zoom out and try a couple more just for fun. Let's go a different color, and let's really sort of spread it out. So let's go with something like 2x to the 4th, y to the 3rd, minus 7x to the 5th, y to the 6th, plus 10x squared, y to the, let's go 7th. All right, so what I want to do is try to figure out the degree of each one of these terms. So I see 1, 2, 3 terms. And again, I'm getting that by taking a look at my sort of division, or not really division signs, but my breaks in the polynomial, which are my plus and minus signs. Now, I'm just going to focus in on the exponents. This is 7, this is 11, this is 9. And I'm looking at them each individually. And so if I had to come up with the degree of the whole thing, it's going to be the largest one, which is 11. All right? And this is a good example of where it's not necessarily always the one that's written on the left, because you can commute these. You can move them around and whatnot if you really wanted to, but I'm just looking for the largest sum of my exponents, and that's how I find the degree. So let's do a quick little recap here, shall we? We're introducing polynomials. A polynomial is just an algebraic number. All right, and so really it's just a fancy phrase for expression. And what we're going to eventually do is start building up some of these expressions using algebra, wondering what it looks like when we add, subtract, and multiply them. Now, what we care about right now for our introduction is terms. And so we're going to look for our pluses or minuses. And so we have different vocabulary for things that are 1-term, 2-term, or 3-term. And again, just looking for like these little breakers in the expression, the minus, the plus signs. We're also curious about the degree. And that is the largest, usually the largest exponent or the sum of exponents in an expression. So here, x squared minus 9, it's just 2, where we find the largest exponent. But when we start bringing multiple variables in, we have to remember the exponents that are there. Maybe if they're hidden, add them together. So this is 3, and it's larger, so it's going to be, this polynomial has a degree of 3. And then, yeah, we looked at even a harder example right there. So hopefully this is starting to make some sense. Good luck with your homework or practice, and let me know if you have any questions.